Hello again, folks. This is Jason Burnfield again. I was going to go over a detailed description of how the counter circuit itself works on this Cosmic Ray Detector. And so we're going to start right in here. So we've got, you can notice we've got two momentary switches on this side and then a momentary push button switch here. And each one of those is associated with an indicator LED as well. So we have our reset button over here. And when we press that, it sets the counter back to 0. And then over here we have the count switch. If I toggle it, basically every time I press it, it toggles it either on or off. So if it's on, it's counting. If it's off, it's not counting. And then thirdly, we have the mode switch, which again toggles on and off depending on if I press the button. And so if it's off, it's counting single mode, so only the primary counter down in the bottom is actually the one that's being counted, and we see it counting pretty rapidly. If we turn the mode switch on, then it turns coincident mode on, and again, that, like I said in the previous video, that means that both the top and bottom, or primary and secondary detectors, need to count or need to pass a signal at the same time in order for the count to be counted. So let's look at the circuit diagram here to see what's going on. So those the two push button switches on the right of the display, the mode and the count switch, are tied to D flip-flops that are wired in a configuration to toggle on and off states as the input as they get an input pulse. And so every time you press the switch, it pulls that input high and changes the state from whatever it was to the opposite state. And so in the case of the mode switch, when this gets turned on, it's active low. And so if it's in coincident mode, we want this to be low, and if it's low, this LED, because it's tied high, will light, and if it's high, the LED will turn off, and that signal then gets sent through a diode. I'm using diodes here as kind of a poor man's OR gate. It's a simple way to combine two signals into one in an OR function, either or, without them affecting each other. And so I just use diode coupling here. And so what we have is we have the mode signal and the detector 2 signal going to the second input on this AND gate. And so if the mode is on, this is high, this is low. And so then that means that it's only going to count when it gets a signal from the second counter. Where if the mode is turned off and it's single count mode, this is high, and it keeps that tied high all the time, which means it will count only the signals from the first detector, and it'll ignore the second detector. And then, as we see, the second the count function toggles on and off as well. If the count is turned on, this is high, and as you can see, the indicator LED is connected to ground, and so it only lights when this is high, and that signal goes into the second AND gate. And so if the count is high, then it's going to pass the counts from the other circuit to the counter itself. If it's low, it's not going to pass it along. It'll just be idle, and it'll sit here, and it'll always be 0 at the output, and so it won't count. And then the third LED, indicator LED here, is just lighting whenever there's a count coming out into the counter itself. Now the counter is done with 7490 decade counter chips, which basically just count from 0 to 9 in binary, and they're cascaded one after the other for each of the 5 digits. And so over here you can see 7490 chips, and then we have the 7490 chips are down here, and the decoder The decoder chips for the displays are here. And then over here you can see the D flip-flop chip, and over here you can see the 7408 AND gate chip. And so that's a quick rundown of how the counter itself works. Hope you enjoyed it.